Malam Bula. I am Nani Setokalau.
And I'm Moraiwan Balangi, and together we will be presenting on a
elastic bending lamp. So, what is elasticity?
Well, elasticity is often defined as a material's ability to elongate or stretch without losing its original shape.
So, why elasticity?
Well, it is an important property of metals which allows it to be used in certain industries. When was it discovered?
Well, the law of elasticity was discovered in the 17th century in the year 1660 by an English scientist, Robert Hooke.
And what did this law state?
The law states that for relatively small deformations, where the object displacement or the deformation of that object is directly proportional to the load or force applied upon it. Step 1. Identifying the equipment. I'll show you all the equipment that was used. First, our workspace. The equipment written on it. Then we have our supports. Then we have our beams. Not forgetting the force applied. Step 2. Setup of the UTM. It is set up the workspace on the UTM machine. Like this. We intact the workspace onto the UTM machine, sliding onto the workspace, the supports. On top of the supports was the beam. 300 millimeters distance. Then we turn the wheel to intact the beam and make sure that it did not move. Step 3. Computer setup.
When setting up a computer, what must you do? Well, firstly, open the software. By doing this, you'll see a spanner-like icon located on the top left-hand corner of your screen. Clicking this will open up the setting window. In the setting window, you'll see a drop-down menu under Materials. Now click this and you'll select your code name. Since your specimen is steel, you'll select S235 JRC plus C. Once you've done this, you will then enter your value, the displacement value. Since the displacement between the two flushes was 300 millimeters, you will enter the value of 300. Once this is done, you will then click the center of your window and this will automatically generate your maximum force. Once the maximum force is already generated, you will then see if everything is to your liking and satisfaction, click the OK button. This will redirect you back to the software window. In the software window, you'll have a graph, the y-axis and the x-axis. And within this graph, you will see a red line. Now this red line is your maximum force, which is also the critical elastic point.
Beware that we should not surpass the red line as it will disfigure the specimen, eventually breaking it. Virtual representation of elasticity. The elastic region is the place where the material can undergo elastic deformation and withstand a certain load while keeping its original shape.
The elastic limit, as indicated in the graph, refers to the maximum point in which a material can bear certain loads but should not exceed that particular point.
conclude without the aid of the UTM machine, this lab would not have been done. The lab took a duration of 5 to 10 minutes depending on the adjustments on the workspace and the computer software. Realistically, the application of this lab could help engineers with building and bridge constructions depending on the load and the number of floors on it. The limit serves as a warning for excess load to render the construction complex to prevent breakage or failure. Thank you.